The phone was literally shocking my hand when the phone was close to the Wimshurst machine. The screen was shocking my thumb. It was throwing sparks to my thumb, between the phone and my thumb. Not from the Wimshurst machine to the phone, but from my phone to my thumb. It didn't hurt, it just, I felt a shock that discharged it. Very interesting. I do wonder if I put that on the other sphere, if it would spin the opposite direction. Okay, let's try something. Let me discharge this. Okay, that wasn't much there. I still don't know if this will shock me right now. Okay. First, okay, this was turning this way. Let me see if I turn this over. If that's what lets it spin the opposite direction. So I flipped that over so that now the pointy tipped ends are facing the other direction now. This one was facing the other way before. So I flipped that over. Let's see if it spins the opposite way now, just by flipping it over. Oh, got to separate these. Okay. Oh, that's very interesting. It just depends on what direction those tips are facing. That's amazing. That is amazing. We're looking at thrust here. This is propulsion, everyone. This is propulsion. We're cohering the zero-point field. That's what we're actually doing. This Wimshurst machine is counter-rotating in the zero-point field, or the vacuum of space, okay? The very energy that we breathe. This is an enormous Wimshurst machine. It's a beautiful work of art. Okay, let's spin it faster and see what happens here. Okay, it might be stuck. See if I can give it a bit move. Hopefully that didn't burn out my meter. The meter's off, but still. Oh, whoa, what was that? What's that sound? Where's that coming from? Whoa! Just turn the light off and see where that's coming from. I hear energy, but I cannot see where it's going. Okay, let's see what that's spinning now. That might be too close to that arm there, to the neutralizer bar. Let's move it away. I could not see. It might have required me turning all the lights off. If I get too close to the machine, it will shock me. I think this is stuck here. There's a charge there. You see that? It's sticking like a magnetic force. It's sticking to this. This is copper. This is copper right here. Look at it stick to that like a magnetic force. Watch this. See that? It's a copper. This is an anomaly, everyone. This is an anomaly. The Wimshurst machine is not spinning right now. Okay, looks like the charge is all gone now. Okay, let's see if I spin this now, if anything happens. There it goes. I think it was just binding against that. So we have counter rotation and the 0-point field. Remember that. Remember that this is spinning. This is counter rotating, right? Intermittent conduction. Conductive. This is a conductive material. I really like that these brushes are very soft and not scratching the Wimshurst machine. All Wimshurst machines need a soft material touching that so it's not scratching the machine up, right? And look, here the collectors are not even touching the counter-rotating discs. I think they're 3/8 of an inch distance from there. So these collectors are just coming into that field of energy, that charge. These plates are highly charged when they're rotating. Now, if they were rotating in the same direction, I don't think there would be anything there. But because there's counter-rotation and the two discs are close together, that's 100% required that the discs be close together. So we need close proximity, meaning close together, and counter rotation. One disc spinning clockwise, the other spinning counterclockwise. Then we have the neutralizers. These are called neutralizers. Okay, they're at 180 degrees out of phase from one another. I mean on one side. So these two are connected together. And on the other side, those two are connected together. You can see one there. Let's see if I can move this a little bit out of the way. So there's one there. And that goes down over to there. So those are 180 degrees out of phase, if I say it that way, across from one another. But what we have here, what gave the most power, was this one here on this side being at 11 o'clock and the other side being at 1 o'clock when I'm facing this way. Originally I had a 10 o'clock and 2 o'clock, and the sparks were only going up to 2 inches between the two spheres. If I went beyond 2 inches of space, distance-wise, there was no spark. So I changed the neutralizers to 11 o'clock and 1 o'clock, and now I can do like approximately 7-inch sparks. Very powerful ones too. I really like the simplicity of this design. I like simplicity and minimalism in design as one option. If you see here, we have the bar we can adjust. It goes across, has the collector on it. The collector does not touch the plates, but just comes close to it within 3/8 of an inch. There's the capacitor tank, which is approximately halfway filled with BBs, and the BBs have to be a little bit below the circular, I think that's copper sheet inside inside that container. And there's one on this side too. So each let's think about this. Ooh, I just got another idea. Because right now each collector is entering the field of opposites rotation. What if I move one of these away so that this collector is only touching one side and the other collector is only touching the other side? Now the capacitors are also connected to one another, so I might need to experiment with being able to interrupt that connection Now I'd have to think about how to do that because there's a wire that goes underneath the machine that connects those two plates underneath the capacitors. The capacitors sit on a plate, and there's a plastic material between the BBs and that big disc, metal disc there. But isn't that interesting? So there's a capacitance there as well. It has to jump through. There's a capacitor. That's, in a way, that's a capacitor where it has to jump through space, right? Now, when we jump through space, I understand that as a magnification. I mean, one really interesting thing here is that this is something that's very interesting to me. Well, a couple things. One is if I put this up here and this one here, so I'm having this small sphere face the large sphere, right? I can't go that far apart. Watch what happens. Oh, you know what? Let me take this off because it's going to fall. Okay, so I touch the spheres together so I can touch this without getting shocked. But it still can shock me. I still have to be careful. Let me just take all these things off here so we can do our experimenting. Okay, so now what we're doing now is going to show this sphere on top and this one coming at an angle on the side. Now look what it does. See what it's doing? Now it's only like 2.5 inches away, and look what it's doing right now. This is an interesting anomaly. I'm going to call it an anomaly. No big sparks, right? No big sparks. How interesting is that? Now if I go even further, right? Let's see if it does anything differently. Now it's not even doing that. But I hear activity here, I hear charge here. So this could probably jump across and hit my hand if I'm not careful. Okay, let's go the other way now. So now we'll go this way, where that sphere is up and this sphere is down. Now we'll do the same test. We'll start close. But when this sphere is pointing at the other sphere, so this one's down more and this one's on top in a way, I can go much further and the sparks just keep getting much bigger. See that? See that? We couldn't do that on the other side. Look at that jump. You hear all that energy? You hear that? Remember, don't forget, never forget that every part of space has megawatts of energy in it. Right now, actual energy, just like plugging into the wall, except the wall energy has already been transformed and processed, if I say it that way, to be suitable for our electronics. We're processing energy here to make sparks and to do other experiments, but it's important to remember because there's a lot of, how do I say this? There's a lot of, I'll call it education. There's a lot of education that doesn't discuss the energy in space. Very high education does get into that, but as many call it, elementary physics does not mention the megawatts of energy in space, or might even say that it can't be used, right? But then when you get into higher physics, you learn that not only is there megawatts, millions and millions and billions of watts, but it is being used. It's the very essence of what makes all of matter, the material universe. It's what sustains the charge of basically the molecules on an atomic level, right? If I say it that way. And then it's what prevents us from falling through the floor, right? Because this is 99.9% empty space, right? So don't forget that your Wimshurst machine is cohering space. It's cohering it. It's making the energy in space usable. That is a lot of energy there. It would really hurt if we touched that, right? We don't want to get shocked by accident. That happens a lot. People get shocked by their Wimshurst machines. I have to follow all safety protocols and safety procedures, which I'm still learning. But I do my best to not get close to the machine anywhere that I shouldn't be touching. But I will tell you, I had the phone close to this area over here when I was filming it. And when I was touching the phone to make it focus, I was touching the screen, there was a spark between my thumb and the phone. It was sparking like that. Very interesting. I'm surprised the phone's still working. Okay, everyone. True Zero Emission signing off. I am thinking about how to further process and transform this energy coming through the machine. As one example, to charge a battery. Let's say maybe take the capacitors off, maybe running through the energy through a full wave bridge rectifier. I'll just try different things, but also other things too. I want to try touching neon bulbs to the machine, both when the machine is connected to capacitors and when the capacitors are not connected, and put a neon light bulb near it, and also a fluorescent light as well. These are some tests I would like to conduct as well. Okay, everyone, True Zero Emission signing off. Have a great day.